definition of a matrix. What is a matrix? A matrix is a rectangular array of numbers used to store information in a way that makes sense. So it's used to store information in a way that makes sense. And that information, we always put them in brackets, we always contain them in brackets. So for example, if I have something like 2, 3, 4, and 5, this is our information in which we have stored in a bracket. So this is basically a matrix. We have different forms. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is still a matrix because this is our information in which we have stored and contained in brackets. So matrices are also denoted by bold capital letters. For example, if I want to name this matrix, I'll simply say capital A equal to 2, 3, 4, and 5. That is it. So they are just denoted by capital letters. We can also have B equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we can have any letter of our choice. It must not be A, B. We can have many other letters of our choice. It depends on you. Okay, let's go to another part of these matrices. That is the order of the matrix. Okay, so the order of the matrix is simply defined as number of rows times the number of columns. Okay, in this our matrices above, we have rows and we have columns. So the order of a matrix is simply defined by the number of rows times the number of columns. So let's have an example of a matrix. Let's say A, B, C, and D. Okay, so the order of this matrix is going to be the number of rows times the number of columns. So here we are just going to be counting. So let's take the number of rows. How many rows do we have in this our matrix? So this is one row, this is the second row. So we have 2 rows only. Now, the number of columns. How many columns do we have? We have 1 column, 2 columns. So that is simply the order of this matrix. So this matrix is a 2 by 2 matrix. So that is simply the order of a matrix. A matrix cannot only be a 2 by 2 matrix. We can also have A equal to a 2 by 3 matrix. We can also have a 3 by 3 matrix. We can also have a 3 by 1 matrix. We can have many other orders of matrices that we have. The order of a matrix, it's also referred to as the size of a matrix, because here we say that this matrix is a 2 by 2 matrix. We are telling the size of the matrix. We are trying to give the size of this matrix. We have 2 rows, we have 2 columns, so that is a 2 by 2 matrix. So the order of a matrix is also referred to as the size of a matrix. Okay, so there is a general notation that is as such: A equal to Aij brackets close and M times N. Okay, so our M is the number of rows, our N is the number of columns, And this Aij, this just tells us the elements in the ith row and the j column. So when we have an element, let's say we have, okay, here we already have Aij. So Aij is the element that is in the ith row and the j column. So let's take an example. Let's say we have a matrix which is 2, 5, 7, 4, 0, minus 3. Okay, so here let's state the order of the matrix. So remember, the order of the matrix, is equal to the number of rows times the number of columns. Okay, so the number of rows, now let us count. How many rows are in this matrix? So we have 1, we have 2. So write 2 down times. Now the number of columns, let us count again. 1, 2, 3. So this is a 2 by 3 matrix. Remember, I told you that not all matrices are 2 by 2. They have different orders. So this matrix that we have is simply a 2 by 3 matrix. Okay, let me just write the matrix back down. That's 2, 4, 5, 0, 7, and minus 3. Okay, so we want to look for the number which is in the element A, which is in the 1 by 1 position. So we want to look for this number. Remember, we had the notation A, I, J. That was the element A, which is in the ith row and the j column. So here, this our A11. 1 is our I, and 1 is also the j. So this is I, this is j. So now let us look for those positions. We need to look for the element which is in the first row and the first column. The element which is in the first row, the first column. The first element in the first row, the first element in the in the first column. So let's check which element has that description. We see 2. 2 is the first element in the first row, the first element in the first column. Okay, so we can just say A11 is equal to 2. Let's take another example. Let's have a matrix B equal to 10, minus 5, 7, 12, 6, 8. What is the order of this matrix? Remember, we count. The order is simply number of rows times the number of columns. So let us count the number of rows. 1, 2, 3. So we have 3. And the number of columns, 1 and 2. So this is a 3 by 2 matrix. So that is the order. Now let us look for the element which is in the position B, 2, 1. Okay. So remember, 2 represents our row, 1 represents our column. Okay. So we are looking for the second element in the first column. So this 2, 1 tells us the second element in the first column. Okay, so remember this matrix that we had above. We were to look for the element in the position A11. So we are looking for the first element in the first column. The first element in the first column. which gave us 2. So here we are looking for the second element in the first column. Let's go. The second element in the first column. How many columns do we have first? Remember, the order gave us 3 by 2. That means we have 2 columns. We have 2 columns. So we are looking for the second element in the first column. So this is our first column. We focus here. Now, which is the second element? The second element is minus 5. So we simply say B21 is minus 5. And that is how it goes. We may see be asked to find B22. So this is the second element in the second column. The second element in the second column. So we go to our second column. This is it. Which is the second element? 6. So we simply say B22 is equal to 6. As simple as that. Okay. Now let's go to the next part of matrices. That is the types of matrices. We have different types of matrices. We have the different types of matrices based on what is placed where, the type of numbers that should be there, and so on. Okay, so let us take the first type of matrix, that is the row matrix. The row matrix. What is the row matrix? The row matrix is a matrix which has only one row. This matrix has only one row. Okay, example A equal to 1, 2, 3, 4. This is a row matrix. It has only one row. It has no column. So this is a row matrix. Okay. Now let us take the second type. If we have a row matrix, we also have a column matrix. So a column matrix has the same definition. Matrix with only one column. So let's take an example. Okay, let's say B. The first was A, so let's take this second one, B. 1, 2, 3, and 4. So this is a column matrix, a matrix with only one column. That is what we have. So let's take the third type, which is a square matrix. The square matrix. Okay, so now what is a square matrix? A square matrix is a matrix whose rows are equal to the columns. Okay, let's say the number of rows are equal to the number of columns. Let's have an example again. Let's say C is 2, 3, 4, 5. So here, as you can see, the number of rows are equal to the number of columns. Let's count. How many rows are in this matrix? 1, 2. That is 2. And how many columns we have? 1, 2. That is 2. So a square matrix is a 2 by 2 matrix. That is, the number of rows are equal to the number of columns. Let's take the fourth type of matrix. That is a zero matrix. What is a zero matrix? A zero matrix is simply a matrix whose entries are all 0. So all entries are 0. That it just defines it. A zero matrix, all entries are 0. Very easy to remember. Let's say O, since it's a zero matrix. 0, 0, 0, 0. Okay, It must not be a 2 by 2 matrix. It can still be a 3 by 3 matrix. It can be of any size. Sorry, 3. The matrix can be of any size as long as all its entries are 0. It does not matter the order, it does not matter the size, but all the entries should be 0 and we will have a 0 matrix. Let's take the next type of matrix, which is a diagonal matrix. A diagonal matrix. Okay. So a diagonal matrix, only the diagonal entries are known zeros. So all other entries are zeros except the diagonal numbers. So only the diagonal entries are non-zero. So let me show you guys where the diagonal is. So let's say we have D equal to 5 0 0 0 2 0 0 0 minus 3. So this is a diagonal matrix. Why? Only the diagonal entries are non-zero. The rest can be zeros, but only the diagonals are non-zeros. The rest are zeros. That is a diagonal matrix. Let's take the next side. An identity matrix. Okay, an identity matrix now, the diagonal entries are 1. Only the diagonal entries are 1. So let's take an example. Let's say I equal to 1 0 0 0 1 0 0 0 1. So this is an identity matrix. The diagonal entries should be 1 and the rest are zeros. Okay, so let us take an example. Let's take an example. Let's say we have a matrix M equal to let's say 9 0 0 0 0 0 0 0 4. Okay, this is a matrix that we have, and the question is the matrix a square and diagonal matrix? So is it square and diagonal? Okay, let's start with the first one. Is this matrix a square matrix? Now let's go to the definition of a square matrix. A square matrix is a matrix whose rows are equal to its columns, whose number of rows are equal to the number of columns. Now let's check. Are the number of rows equal to the number of columns? Yes, it is a square matrix. It is a square matrix because the number of rows, that's 1, 2, 3, it has 3 rows and 3 columns. So the number of rows are equal to the number of columns. Okay, so now let's take the next one, diagonal. Is this matrix a diagonal matrix? Let's go to the definition of a diagonal matrix. A diagonal matrix only diagonal entries are non-zero. So only the diagonal entries can be non-zeros, but the rest must be non-zeros. But the diagonal matrix, the diagonal numbers, the diagonal elements can be non-zeros, but the rest should be zeros. So yes, this is a diagonal matrix because only the diagonal entries may be non-zeros. And here we have 9, we have 0, we have 4. So only these people are permitted to be non-zeros, but this is still 0, but it does not mean that it is not a diagonal matrix. Yes, it is still a diagonal matrix. So yes, that is a diagonal matrix. So let's have another example. Let's say K is equal to 2, 3, 4, 5, 6, 7. Let's find K12, K21, K23. Okay, so first of all, let's take the order. What is the order of this matrix? Order, remember, is equal to the number of rows times the number of columns. So how many rows do we have? Let's count. 1, 2. So we put our 2. And how many columns do we have? This is 1, this is 2, and this is 3. So it is a 2 by 3 matrix. Now let's take the first one. What is K12? K12, that is the first element in the second column. The first element in the second column. 1, 2. First element in second column. So let's go. Let me just write the matrix back. K equal to 2, 3, 4, 5, 6, 7. So we are looking for the first element in the second column. First of all, let us locate our second column. This is a second column, right? So which is the first element? We have 3. So our K12 is simply 3. Let's go to the next one. K21. K21 is a second element in the first column. Let's go to the first column. What is the second element? 5. 5. K23. The second element in the third column. We go to the third column, which is the second element, 7. And it is as simple as that. So remember the definitions of matrices. Remember the order of the matrix, how to write the order of a matrix, that is the number of rows times the number of columns. Remember the types of matrices. A row matrix has only one row as its name. Column matrix the same, only one column. The square matrix, the number of rows should be equal to the number of columns. A zero matrix, all entries should be 0. A diagonal matrix, only the diagonal entries may be non-zero. And the identity matrix, the diagonal entries are 1. So it is as simple as that. Thanks for watching this video, and I'll see you guys in the next video.